Videos about types of organic reactions. So the keyword in the question is the correct product for this reaction right here. And the concept of this question is the electrophilic addition of hydrogen halides to alkenes. Here we have an example of an alkene, which is butene, and a hydrogen halide, which is a hydrogen iodide. So in a hydrogen iodide, iodine is more electronegative compared to hydrogen. And so what happens is the pair of electrons between the two are more attracted towards the iodide and making it slightly less negative, whereas the hydrogen is slightly positive. As the hydrogen iodide approaches the butene molecule, hydrogen being more positive, slightly more positive, will be attracted to the pair of electrons in the alkene. Pair of electrons in the double bond will go to the hydrogen, and their pair of electrons between hydrogen and iodine will go to iodine. The result is an intermediate product where the hydrogen is bonded to the first carbon, the second carbon is positive, as well as an individual atom of a negative iodine. And the electrons in that negative iodine will be attracted to the positive carbon and result in the final product. Just something looks like this. A way to explain this is using the Markovnikov's rule. So the hydrogen prefer the first carbon, the carbon that is bonded to the most hydrogen. So it is already bonded to two other hydrogen. Whereas the second carbon is more preferable for a halogen because it is bonded to the most substituent group. So here we have the substituent group of CH2CH3. Because the surrounding carbon will add to the inductive effect, allowing this carbon to be the most stable, which is most preferable for a halogen. Back to the question, we can see from this reaction here, it is the breaking of the double bond, so hydrogen and bromine has the option to bond to either the first or second carbon. Hydrogen will prefer the first carbon right here because it is bonded to the most hydrogen, so it's bonded to two other hydrogen. Whereas the bromine will prefer the second carbon because it's bonded to the most substituent group. You can also see the second carbon has the most inductive effect from three other carbons, making it the most stable. So the answer is answer C.